Okay, bridge students, we're up to the third video, second concept in our exploration of the Pythagorean theorem. And today we're going to look at the converse of the Pythagorean theorem. Essentially, we're going to turn the Pythagorean theorem around, turn it on its head, if you will. So the objective says this: students can apply the converse of the Pythagorean theorem to determine if a triangle is in fact a right triangle, the converse. All right. So before we get into this, I want us to just review where we're at so far. I've given you three representations of the Pythagorean theorem. The first one is our verbal representation. Here, you can read that again. Right here we have a geometric picture of the same thing. And go back and look at the first video if you forgot about that, but this little picture should be familiar to us by now. And then finally we have this algebraic representation here, which is going to be key for us with the converse. So I said earlier, now I'm moving forward, that we're gonna be looking at this converse, and that what I meant by the converse is we need to turn the Pythagorean theorem around on its head, essentially. So let's take a look. You might want to think here before I start writing, like what would be going on if we turn the words right here, essentially upside down. All right, so now let's do it. So, turning it upside down, we'd say if the sum of the squares of the lengths, L-E-N-G-H-T-S, of the two legs of a triangle equal the square of the hypotenuse, or what we suspect will be the hypotenuse of a right triangle. If the sum of the squares of the lengths of the two legs of a triangle equal the square of the hypotenuse, then the triangle is a right triangle. So this is, the Pythagorean theorem is one of those interesting mathematical statements that works both ways. Both ways. The if-then statement, we can turn it around on its head and it still works. So let's, with that background, let's take a look here. Let's look and see whether these are three side lengths I've given you for A, B, and C. I have not given you units. I haven't drawn a picture. It's kind of abstract here. But we want to see whether these three side lengths are going to form a right triangle or not. And so to do that, here's your process. Every time we say A squared plus B squared equals C squared. And we don't know. The whole point in this exercise is we don't know. So we're going to put a little question mark above the equals sign. And then all we do is we plug in. Like here, this is 6 squared plus 10 squared. Keep our equation in order. This is still an equal sign. The question mark's still in place. We don't know. We don't know the answer. Here's 13 squared. This is 36. 10 times 10 is 100. 13 times 13. Think about it, guys. Do you remember? It's 169. Okay, now the question is, are those going to equal each other? And heck no. Heck no. We have 136 does not equal 169. And so by the converse of the Pythagorean theorem, this is not a right triangle, or these side lengths here that I gave you do not form a right triangle. Here, I'll represent triangle that way. Not like that. Not like a traffic cone here, not like that. Okay, not a right triangle. All right, so let's look at another scenario. Let's say, just for fun and games here, that A is maybe, well, let's keep A at 6, but let's put B at 8 and C at, say, 10. Okay, And we want to know whether those three side lengths that we've been given form a right triangle. And once again, and this is essentially all you'll do for this lesson, is you're checking it out. You're going to apply the Pythagorean theorem to situations like this. We have, well, let's see, we're going to plug in 6 for A. So well, actually, let's not get ahead of ourselves. This is going to be 6 squared plus 8 squared. And we want to know, does that equal 10 squared? And now I can say 6 times 6 is 36, and 8 times 8 is 64. And, the question at hand becomes, does 36 plus 64 equal 100? And, well, gee, let's do some mental math here. 30 plus 60 is 90, and 6 plus 4 is 10, and 90 plus 10 is 100. So, yeah, 100 definitely equals 100. So we can say, yes, these side lengths make a very beautiful right triangle. And that, ladies and gentlemen, is what we're going to be doing with the converse of the Pythagorean theorem. I hope you have fun with it.